Hi friends, welcome to my YouTube channel. This is lecture number 19.2 and today we are going to study parameter calculations for one phase half wave control rectifier with R load. So first we will calculate the average value of this rectifier. So to calculate the average value, simple formula is 1 upon T integration 0 to T V naught dt, and we know that we get waveform of output voltage from alpha to pi only. That's why there is no need to integrate in remaining part from 0 to 2 pi. Only we need to integrate from alpha to pi. So simply integrate, and here time period t is equals to t pi. So 1 upon 2 pi integration alpha to pi Vm sin omega t d omega t. Very simple integration. We get V naught average is equals to Vm upon 2 pi 1 plus cos alpha. Now if I ask you why this rectifier having thyristor is called control rectifier, then answer is in this expression. Here we can see that our average output voltage of rectifier depend on this alpha. If we change this angle alpha, then output voltage also changes. So we can control the output voltage by controlling this angle alpha. So that's why due to this alpha, this thyristor rectifier are controlled rectifiers. Next is average output current. It is simply equals to V naught average by R, and we know that V naught average is equals to this, and that's why we get V naught average is equals to Vm upon 2 pi R 1 plus cos alpha. Now what is RMS value of output voltage? This is the formula. It is simple formula under root of 1 upon T integration 0 to T V naught square d omega t. We know that equation of output voltage is Vm sin omega t and time period is 2 pi, and we have to integrate only from alpha to pi because we get output voltage waveform from alpha to pi only. So on integrating this we get V naught RMS is equals to Vm by 2 under root of 1 upon pi in bracket pi minus alpha plus sine 2 alpha upon 2. Now what is output RMS current? It is simply equals to V naught RMS by R. Here load is voltage step. Why load is voltage step? Because it is resistive load and current and voltage waveforms are similar. That's why it is a voltage step load, and it is a half wave control rectifier, and it is a one pulse converter. Why it is one pulse converter? Because from 0 to 2 pi we are getting only one pulse of output voltage. That's why it is one pulse converter. Now output power P naught. As I already told you, in case of voltage step load, output power is given by V naught RMS into I naught RMS. So here, while in case of current step load, output power is equals to V naught average into I naught average. But in case of voltage step, it is V naught RMS into I naught RMS. If I ask you, what is power factor? So power factor, simply we know that to calculate power factor we have to equate input power equals to output power. Why we have to equate it? Because we know that here this circuit is loss free, or we can say that thyristor is ideal. That's why there are no losses across thyristor, so we can equate input power is equals to output power. If we put this, and we know that this source current is equals to this output current, so that's why this Is RMS is equals to I naught RMS, cancel out them, so we get input power factor cos phi is equals to V naught RMS by Vs RMS. So this procedure to calculate input power factor is same in all rectifiers. Okay, next is what is conduction angle of thyristor. We know that we get output voltage from from alpha to pi. So we get output voltage only when thyristor conducts. So simply thyristor conducts from alpha to pi. So that's why conduction angle of thyristor is pi minus alpha. Now what is excitation angle beta? Excitation angle beta is simply equals to pi because we get current up to pi. So beta is simply the angle up to which we get current, and we get current up to pi, that's why beta is equals to pi. What is peak inverse voltage? We can clearly see in this waveform that peak inverse voltage is Vm. So that's why peak inverse voltage is Vm. Now what is circuit turn-off time? To calculate the circuit turn-off time, we must know the angle for which thyristor is reverse bias. So here we can see that thyristor is reverse bias only for this plate. And what is this plate? This is simply equals to 2 pi minus pi. So that's why it is simply equals to pi. So the circuit turn-off time, we can calculate it from the angle for which thyristor is reverse bias, that is equals to 2 pi minus pi. So simply we get pi, and so that's, if we equate this omega tc equals to pi, we get circuit turn-off time tc is equals to pi by omega. So this is very simple derivation. So procedure to calculate all the parameters is same. If you know the circuit, you can plot the waveforms, and if you know how to plot the waveforms, then you can calculate easily any parameter related to any rectified circuit. So the important thing is you must know the concept. So this is all about this video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.